circular portal, about 20 meters across, suddenly appears at the bottom of the Challenger Deep, the deepest point in the ocean, and the other end opens up somewhere else. Say over the Mars Curiosity rover, so it finally finds liquid water. The short, surprising answer: the oceans would not empty overnight. Even with that enormous hole, the planet's oceans are just too vast. At first glance, you'd expect a dramatic whirlpool and a rapid fall in sea level. In reality, the flow would be huge, but the oceans are stupendously large, so the mean sea level would drop by a tiny fraction each day, well under a centimeter. The opening is big compared to a person, but tiny compared to the ocean, and the depth and scale of the basins prevent a single drain from producing the cinematic maelstrom you might imagine. Even though water would rush through at tremendous speed, the surface would not necessarily collapse into a neat giant funnel. If we cranked things up and created many such drains, or much larger ones, the picture changes. As the global sea level fell by tens of meters, the world map would be transformed. Land bridges would appear. Formerly island nations would join continents, and coastlines would redraw themselves. At around a 50-meter drop, places like Great Britain, Sri Lanka, New Guinea, Java, and Borneo would join their neighbors. After centuries of struggling to hold back the sea, the Netherlands might finally be dry at last. As the drain progresses to 100 meters down, the Black Sea would detach from the global ocean and stop losing water. By 200 meters, massive new landmasses and inland seas would appear. Indonesia would blend into a continuous mass, and much of northwestern Europe would be reorganized. At a 500-meter fall, Japan would become a causeway linking Korea and Russia. When you remove the top kilometer of water, New Zealand would expand dramatically, and previously isolated regions could be connected by vast land bridges. After several kilometers of sea level loss, most oceans would fragment into disconnected basins, and the draining would stall. Even when the drains finally stop, a lot of water remains, mostly shallow seas and a scattering of deep trenches a few kilometers across. But vacuuming out that much of the ocean would wreck the climate and ecosystems. The global heat balance, ocean currents, salinity, and weather systems would all be thrown into chaos. Marine life would collapse on a massive scale, and terrestrial ecosystems would follow. The result would almost certainly be a biosphere-level crisis with mass extinctions across many groups. In spite of that cataclysm, human survival might still be possible in niche scenarios. Populations could, in theory, migrate to newly exposed continental shelves, tap isolated deep basins, or engineer refuges, but doing so would require extraordinary foresight, resources, and cooperation. The physical possibility of surviving is not the same as its practical likelihood. The social, ecological, and logistical hurdles would be enormous. So, a single 20-meter portal at Challenger Deep would drain the ocean slowly on human timescales, not in days or years, but over centuries to millennia. The world would be remade, shorelines would retreat, new lands would appear, climates would swing wildly, and the biosphere would pay a terrible price.